Welcome to Episode 8, Detailing Components. In this tutorial, we're going to cover the following. We're going to make some assumptions. We'll have a system overview. We'll create the Curtainwall Sill section unit. Then the Mullion side elevation. We'll load some out-of-the-box components. I'll create the line weights. And finally, we'll annotate the detail. We're going to start with making 3 assumptions. We've already chosen the manufacturer and product we want for our basis of design. We've decided on the size of our glazing, like 1/4 inch versus 1 inch, and we know whether it's a single, double, or triple pane glazing. And third, we're going to use this for detailing, and not embedding in the detail component into the model component. Here's a system overview. When selecting a system, make sure you download the following: the detail guide, download any BIMs the manufacturer might have, and download any DWGs for detailing. Let's look at the system from Kawneer. We have the mullion in gray, the glazing in blue, the wood shim in orange, and the baccarat and caulk in red. Think about how you want to use these components separately in the detail view. We'll have the curtain wall in gray, the glazing in blue, the curtain wall side elevation in red, some of the out-of-box elements in orange, and annotations in purple. Let's create a detail component for the mullion section. I'm going to create a new detail component and import the CAD file I downloaded from the manufacturer. Link in the CAD file and change the colors to black and white. There's no need to explode the DWG. We're going to trace over the existing lines to make filled regions. The aluminum frame component will be static. There isn't a need to make this geometry parametric. However, the mullion elevation and glazing components will be parametric, so they stretch with the extent of the detail view. Create a new filled region type called solid gray. Choose the gray color. I like to use this gray for gaskets. Change your default filled region back to solid fill black. I'll start with the cover plate as that's the easiest. Then I'll do the curtain wall, then the screws, then the gaskets, and finally the remaining line work. Create a new filled region and choose the solid fill black. I use solid black so I can see what's been converted. Any solid color will do. Then we can use the pick line tool to trace the boundary of the regions. Not all lines can be selected due to the Revit line length limitation, which has a minimum length of 1/32 of an inch. In this area, the round edge cannot be picked due to the length, so I had to take creative liberties and use the pick arc. For some of these intersections, you can chamfer the corners, and some of the larger corners, you can use the radius tool. Chamfering works here because most of these corners just can't be seen when printed to PDF or paper due to the line weights, so don't get too caught up here. In this section, you can see I wasn't able to chain select the entire boundary. I have to create my own arcs. I'm going to skip these small triangles that are used to bite down on the gaskets, as they're not visible when you print. You can see here that if you manually pick these arcs, you'll have a very small line segment connecting them. I'll delete these lines and draw my own arcs. This next geometry is quite similar to the last, so I'll just speed through it. This bottom filled region can be chain picked, except for the parts on the far right. I'll chamfer this bottom right radius. This line segment is less than 1/32 of an inch, so I'll start by drawing a horizontal line at 1/32 of an inch, then going back to the top left and closing the loop. I'll create a new filled region for this end clip inside the mullion. Most of it can be chain picked. In this section, I'm going to shrink the boundary of the region to compensate for the screw head. It won't be visible anyway. Let's take the same process for the gaskets. This second gasket is quite tricky due to the quantity of small segments. I can pick some of them, but others I can't. Some of the radii are too short as well, so I'll have to chamfer them. I'm going to only sketch the top half of the geometry, then mirror it about the centerline axis. This will reduce the amount of rework. As you can see, this process is quite laborious. This detail component can be used 10 times in the same project, and potentially in future projects. So I see this as an investment in my project documentation and my future library. Most of these sill details can be reused as a starting point for the jam and head conditions as well. Here you can see the order of the chamfer is important. Always chamfer to make the lines longer at first, then reduce. This gasket was a little more defined in the PDF than it was in the DWG. I'm going to just sketch it here and leave out some of the compression voids. I'll now offset the male edge of the gasket by 1/64 of an inch. For this bolt, I'll use a masking region. We can now start playing with where we want these geometries to exist, for instance in the background or foreground. I'm going to push this geometry to the background. I'm going to hide these two filled regions so I can chain select the boundary of the screw. I'll use a masking region for this as well. I'll also copy the boundary to the screw above. Then I'll close the sketch. For these screws, I'll use some line work. This may not be necessary, but I think it adds context to how this curtain wall is assembled, so I'll include it. I'll use line work for the weep holes here on the left as well. This is really important for communicating how water is directed away from the facade. I'll create a detailed line for where the center line of the glazing is, and the bottom of the glazing. Let's select all of these items and move them out of the way, and align them to the origin point of the component. I'll align the center of the glazing to the left and right center line. Now I'll move the imported DWG to the side. Let's add a reference plane for the glazing to sit on. This will make it easier to place the glazing later. I'll take a moment to clean up some of the line work, and I'll hide some of the filled regions to help with this process. Let's finish this detail by creating the remaining gaskets. Sketch out the boundaries here over by the CAD file, but not the lines of the arcs that we customized. Now I'll move them into place and copy the correct line work from the new filled regions. Then I can finish the sketch. For good measure, and to make sure I don't have any weird object styles or line styles and patterns from the DWG import, I'm going to copy and paste to the current view in a new family. I'll change the scale and the visual display, and finally we can change the solid black filled region to aluminum. Now we can load this into a project or save it to a directory. Now let's take a look at the glazing component. What we want to create is a family that stretches vertically. This glazing is 1 inch thick and a minimum of 2.5 inches in length. It also has two 1/4 inch sheets of glass. Next we'll create the glazing with the detail item line-based template. Let's create an offset of 1/2 inch for the top and the bottom, and offset a copy of each by 1/4 inch. I'll draw segments to the left and the right to enclose the rectangles, and I'll lock down the left and the right sides. This could have been sketched more efficiently if I used the rectangle function. Before I close the sketch, change the two lines on the right side to invisible. Next, I'll create a gasket at the bottom of the glazing. I'll make it 1/4 inch thick, and I'll match what I did in the Mullion component and make it gray. Load this into a project with the Mullion. We can place this at the intersection of the glazing centerline and the bottom that we created in the Mullion family. Now let's create the Mullion side elevation. Here the gray is the side elevation. The blue represents the aluminum edge, the orange represents the gaskets, and of course we want this to extrude upward. Back to the project. I'll create some line work for the location of the aluminum edges and the gaskets. Let's add another line for the center line of the glazing. I'll copy to clipboard all of the sketch lines, create a new family from the detail item template. First, before I paste, I'm going to add a horizontal reference plane and give it a height parameter. This parameter will be instance-based, so it can be stretched in each view. Lastly, I'll change the default value to approximately 4 inches. This component will be parametric like the glazing. It's a rectangle with 2 lines representing the gaskets. I'll use the same origin as the curtain wall, so it can be easily aligned in the project. Paste your line work and move it into place. Make sure to align the glazing centerline to the left and right centerline. Next, create a masking region and sketch a rectangle. Lock down the top and bottom lines to the reference lines. Change the top and bottom line work to invisible and close the sketch. Delete the copied in lines that are now replaced with the masking region. Align and lock the endpoints of the gasket lines. Send the masking region to the back. Save this to a directory and load it into the project. You can delete your sketch lines in the project and insert a new instance. Now that we can start to assemble this detail, I'll lock the bottom to the Sill Mullion. I'll send the geometry to the background so it can actually show the glazing. I'll also lock the top of the glazing to the top of the Mullion elevation. You can see they now move together when stretched. Let's load some pre-made families. I'm going to load in some out-of-the-box Revit components to match what the manufacturer shows in their detail. I'll load in the nominal cut lumber section family, the joint sealant and backer rod section family, and the brake line family. I'll start with the brake line. I'll place it and adjust it as desired. You can even lock it to the Mullion elevation component so they move together. I'll rename the lumber to shim and make the size 1/2 inch by 3 inch. which is seen in the detail book but not in the DWGs. Create a new instance of the shim and move it into place. I'll add the 1/2 inch joint sealant and backer rod family as well. Add one to the back and one to the front. Make sure you don't cover the weep holes. As you can see in this last segment, a detail can be created very quickly if you have all of your components pre-made. Next up is line weights. Line weight aesthetics vary with each firm. Some like to only bold in the exterior edge of the detail. Some like to bold in everything that is cut. I have more freedom here, so I'll show you my best practice. Let's measure to see how low the bottom of the glazing sits below the gasket. This glazing sits 9/16 of an inch below the top of the gasket. Let's edit the glazing component. I'll create a reference plane that sits 9/16 of an inch from the left side. That is where the bold line will terminate. Edit the masking region now. I'll create an object style called O4 Black Solid. I like to name my object styles as the properties are read left to right in the dialog box. This has two benefits for me. It sorts by line weight, and it makes it easy for people to decode the object style's purpose. Change these lines to O4 Black Solid. Finish the sketch and load it in. To finalize this, go to the project's object styles and create an O4 Black Solid. Change the line weight to 4. And now you're done. Now we're going to edit the Sill Mullion family. Create the new object style and name it O4 Black Solid. Edit the gaskets and change the boundary lines to O4 Black Solid. You'll notice I'm selecting too many lines and I'll have to change it in a moment. Do the same for the cover plate and the top right side of the mullion. Load this back into the project. Just to clean up the line weights, I'll move the brake line component to the front. Let's understand what we want to convey in this detail. I want to convey both product information as well as instructional information. To do this, I can use text or even better, a tag. Let me show you. Let's select the glazing family. Comments are an instance parameter, which means they vary per instance applied. Type comments vary by their type. So here we're going to place the CSI descriptive term. and in the instance we'll place the instructional or varying information like paint color, second floor only, etc. By having both instance and type values, we can increase the information in the tag and decrease the number of types required to do so. I'll create a multi-category tag. This way it can be used on detail components or in 3D views or floor plans. We'll start by creating a label. Choose the type comments, then the comments parameter. For the comments, change the spaces to 0 and add a prefix of a comma and a space, and then hit OK. This will allow the text to add a comment space if there is a comments value. Change the horizontal alignment to the left. Move it into place and adjust the label length as needed. Reduce the leader border offset from 5/64 of an inch to 1/64 of an inch. This is a personal preference of mine. I'm going to change the text to blue. This will help me differentiate tags from text later on in the project. I can change it to black before printing. Now let's load it into the project. Tag your glazing panel. I'll change the leader to arrow filled 15 degrees. This is another personal preference. Let's create 2 new instances of the glazing off to the side, and we'll tag them too. I'll edit the type and update the type comments to glazing. You can see how it auto-populated all the other instances of that type. Now let's add comment values to the second instance and see what happens. I'll annotate it as type 2. Do you see how the comment space was added only after there was a value? See how it didn't change the first instance or the third? I'll edit the other for type 3. Use this function carefully, as anything that exists in multiple places should likely be another type, so as to reduce errors. This should be a one-off for directions only. Now we've successfully avoided the pitfalls of keynotes. One limitation to keynotes is that sometimes we need type and instance information available in our details. I'm planning videos dedicated to line weights and annotating, so if you're interested, check back in soon. Thank you very much for watching. If you enjoyed it, please like and subscribe. Cheers.